Not really entirely sure what we want to know about this, but we'll go through the beginning of the notes. So what do you know about triangles?
They're three-sided.
3 sides, 3 angles.
3 types.
It's a shape. It's not a square. Wow, y'all are so smart. Creepy.
Yeah.
What's up?
The angles add up to equal 180.
The angles add up to equal 180. Yeah. Totally not even hitting on that yet. That's tomorrow, I think.
That's 3 angles.
It's affiliated with the Olympics.
Oh, goodness gracious. And then we went a little too far. Basically, triangles, tri meaning 3, 3 sides, 3 angles. So since a triangle has 3 sides and 3 angles, we can classify what that triangle is based on its sides or its angles. So basically, that's all that's saying. If we look here, all triangles have at least 2 acute angles. What does that mean to be acute? Less than 90, but we use the third angle to classify. So we're always going to have 2 angles that are less than 90, but then our other angle could be less than 90, it could be greater than, it could be equal to 90. So that's the angle that we're going to use to classify. So if we look here, these are the types of triangles that we have. We have an acute triangle, which has 3 acute angles, which we said acute means what again? So less than 90 degrees. We have an equiangular triangle, which is 3 congruent acute angles. What does it mean to be congruent? Yeah, they're the same, they're equal. So congruent, the angles are equal. How do we know that something is congruent? They have the same value, or if it has those little marks right there. Either way, sometimes it'll give us the congruence marks, sometimes it'll just tell us that they're all equal, just kind of depends. We have an obtuse triangle, which has 1 obtuse angle. So what is obtuse? It's greater than 90. And then right triangle, which how many degrees is a right angle?
90.
So equal to 90 degrees. So again, stuff that we know pretty readily. So we're just going to classify triangles based on what those angle measures are. So if we look at example 1, if we look at A, what's going on there?
Equal angular.
And how do you know that?
They are all congruent and they are acute.
Equal angular. Yeah, so 60, 60, 60, they're all equal. They are equal angular. Okay? So that's all we're going to be doing for right now is just classifying. So what's going on in B? Why obtuse? Because there's one that's greater than 90, so it isn't obtuse. So even though there's a 49 and there's a 34, even though both of those measures are acute, as long as I have 1 obtuse angle, it is an obtuse triangle, yeah? Feeling okay?
Yeah.
Go ahead and try practice 1. It should be pretty basic. On C, before you guys get started, classify what all 3 of those triangles would be, because it doesn't specify which one. So go ahead and take a second to do that. For C, what are the 2 little triangles both? How do you know? Because there's 90 degrees, but I only see the perpendicular mark in one triangle. How do I know the other one is also perpendicular? They just are. Yeah, so I'm hearing it over here. It's also a linear pair. What? We're going to use that back in chapter 1. So they make a line. If half of it is 90, the other half has to be 90. So whenever one is perpendicular, whatever's next to it is also perpendicular. And then the big triangle, PQR, was what? Obtuse, right? Because you add those 2 angle measures together. But I didn't ask you to find it. I just said to classify it. Any questions on any of that so far, guys? Okay. I know it feels like we're going through it kind of fast, but it shouldn't be too terribly bad. If I stop drawing on the page, maybe. So we just classified by angles, but we also said triangles had 3 sides as well, right? So we can also classify triangles based on what those sides are. So if we look here, we have an equilateral triangle, which is 3 congruent sides. So congruent, we said, is what again? They're the same. Congruent means the same. So each one of those sides is going to be exactly the same. Okay? They're going to be equal to each other, which will be important when we start having expressions and we're having to solve. So then we have an isosceles triangle, which has 2 congruent sides. Okay. I was trying to think of like a clever way to remember that, and I was going to say that there's 2 S's, but then I realized there's 3 S's, so that wouldn't really make sense logically. So just remember isosceles has 2 congruent sides, and then scalene is our last one, where there's no congruent sides. It has, oh, which one has 2 L's?
Both words.
Oh, like isosceles triangle. But then so would scalene triangle. However you feel the need to remember it, go for it. Scalene, I was taught like scalene, it's kind of leaning because it's lopsided because nothing's equal to each other. So it just kind of depends. Some of us might be good at just remembering it without needing quirky little tricks. I don't know, that's how I learn. So whatever works best. So equilateral, all of the sides are congruent. Isosceles, 2 of them are congruent. In scalene, they're all different, okay? So if we look at these examples, or the example A, AB is congruent to BC, which is congruent to AC. How do I show something's congruent? The little symbol that's there. Or I can put a little tick mark and say AB is congruent to BC, is congruent to AC. Well, what's going on there? How many congruent sides do I have?
3.
Yeah. So it is an equilateral. Lateral. Okay, hopefully you guys can read my handwriting. I keep like moving the page when I'm writing on it. What's going on B?
It's a scaling.
Yeah, so are any of my sides the same length? No? So what is that going to be called? Scalene. Okay. Any questions so far? If we're not sure, just use that little picture to remind us. Go ahead and take like 30 seconds to do practice 2. Because all 3 sides are congruent. They're all the same, right? That's what you were telling them, right? Cool. Any questions so far? Okay. If we flip over, okay, this is when we start to have to think a little bit more. So classify triangle JKM if M is the midpoint of JL and explain your reasoning. Then classify triangle KML. So if I'm looking here, what do I know about something if it's the midpoint?
It's half of it.
That it divides it in half. So what does it tell me my midpoint is?
75.
Okay, well, yeah, y'all totally did that already. It says M is my midpoint, right, of JL.
Yeah.
Okay, so if the entire length of JL is 1.5, well, what is half of that? 0.75. So which segments are going to be 0.75?
J and
0.75 and 0.75, right? We can also say that because M is the midpoint, it makes these 2 congruent. So same thing, you just told me that they're both 0.75. I just showed that they're congruent with the little tick marks. So what triangle does it want me to classify first? Triangle JKM. Okay, so JKM, I'm talking about J to K to M. Well, what's going on there? How do we know they're all congruent?
The little marks.
Because the marks tell us, and they all have the same measurement, right, as far as we can see. So if every one of those legs of the triangle is 0.75, well, then it's going to be, whoops, that's a highlighter. It's going to be an equilateral. Okay.
Why can't it be equal AU?
Do you know anything about those angle measures?
Oh, we're talking about the side.
Yeah, so that'll be what we have to figure out. Am I classifying it by its angles? Did it give me angles? Or am I classifying it by its sides, depending on what it gives me? So here it gives me side measures, so it'll be equilateral. Most of the time it'll specify what it wants you to classify it as, though. So if I look at the other one, triangle, goodness gracious, KML, well, what's going on there? If I have KML.
2 congruent sides.
Yeah, so I have, what is it that I have? Whoops, if I can get a pen. Goodness gracious, yeah, so I have this leg right here, which is 0.75. This is here, which is 0.75, and then I have a different one that's a different length. So 2 congruent sides is an isosceles. 2 2 E's. There you go. Okay. I don't know. However you want to remember it.
One side is isolated.
Oh, one side is isolated. That would make a lot more sense. Good job, Jacob. Snaps to you. Okay. Any questions on example 3, guys? You feel okay with it? Cool. Go ahead and try practice 3 then. It tells us that y is the midpoint. So I know it's a little blurry up there. So this is 8.4. Well, if y is the midpoint, half of that would be 4.2. Do I have any congruent sides there? No, it tells me that this is 3, this is 4.5, this is 4.2. So if nothing is congruent, it's scaling. Okay. If we look at example 4, so now we're just going to be using what we know about triangles, using what it gives us to find the side lengths, or to find x, depending on what it asks. So here it says find the lengths of all 3 sides by using your knowledge of classifying triangles. So what kind of triangle would this be? Isosceles, why? Yeah, because I have 2 congruent sides. So congruent, what's another word for that? Equal. So I have 2 sides that are equal. So what do you think I'm going to do with the expressions on those sides? Yeah, if they're going to be equal, if they're congruent, they're the same, I'm going to show that and I'm going to set them equal to each other. So if I want to solve for x so that I can find those sides, well, what is it that's going to be equal? Yeah, AC and CB. I just moved that paper. So 4x plus 1 is equal to 5x minus 0.5. Okay. Do we all understand why we're setting it up that way? Okay. So what do? How do I solve for x? I simplify. So if I subtract 4x, I'm left with 1 is equal to x minus 0.5. How do I get x by itself? Add 0.5. And x is equal to what? 1.5. Cool. Am I done? No, because what does it ask me for?
Find the length of all the sides.
Okay, so if I want to find AC, what am I going to do?
Multiply 4 times 1.5 and add 1.
Which is what? 7? Cool, I'll trust y'all on that. What do I do to find BC? And what does that give me? Did I have to solve for both of those? No, I could have just recognized that since they're equal, well, if one is 7, the other one's going to be 7. But that's also a good way to check yourself and make sure that you're doing your math right. If it comes out wrong and they should be equal, then maybe it's time to go back and check something, right? And then how would I find AB? Plug it in. Same thing I've been doing. So 9 times 1.5 minus 1 gives me what?
12.5.
Any questions on anything we've done so far? We feel okay? Have we seen these words and stuff before? Yeah? So we feel okay? All right, go ahead and take a minute to do practice 4, both A and B. So just recognize what it is that's equal, what it is that's congruent, and go ahead and do those. Why did you set them equal to each other? Because they're congruent. They should be equal. So have 3x minus 4 is equal to 2x plus 7. What did we get for x? 11. Anybody need me to work that out? No? We know how to solve? What is the question asking me for? Yeah. So it really just asked for what x was. What if I wanted to find the other sides? What would I do? Plug it in. So if I asked for the length of ln, well, 3 times 11 minus 4 would equal 29. Okay. It doesn't ask for it there, but just in case it does, we know how to solve it. So if ln is 29, what would mn be? 29, right? It should also be the same. But it just asked for what x was there. What about on B? What did we do? What do you know about equilateral triangles?
They're equal on all sides.
About this.
All of the sides are equal to each other.
Dad,
Good.
together, but no, you know. No,
So what do we do to solve here?
It's like any each.
But all of them equal to each other?
Actually, no. You could just put two equal to each other, find y, and then plug
Yeah.
it into the rest of them.
So that's the thing. All of the sides are congruent. All of them are going to be equal to each other. But I don't need to solve all these different equations. I can just choose two of them
Yeah.
and set them equal to each other and solve. Because from there, they're all going to be exactly the same. So I would choose, I don't know, 2y plus 5 is equal to 3y minus 3. And then just solve. So what is y equal? What did we get? Oh, 8. Yeah. You subtract 2, you're left with y equals at 3, 8. Yeah. So if y is 8, well, it's going to be the same for all of them. So if I wanted to find the side length excuse me, if I wanted to find what one side is, all I have to do is plug it in, right? So what would the length of all those sides be? 21, right? They would all be 21. So again, it doesn't ask for it, but if it did, then I would know how to solve it. Any questions on anything, guys? We feel okay with this? On example 5, find x and the missing side lengths and classify the triangle. I would probably classify it first. So what kind of triangle is this? It's an isosceles because of what? Isosceles, I think that's how you spell it. Yeah, I have two congruent sides, two equal sides. So if they are equal, what should I do with them? Put them equal. I know it sounds really redundant, but some of us forget that sometimes, so I'll just be annoying and keep reminding us. So how do I solve for x? I heard add 11. That's what I would do.
Just subtract 5.
Or you could do that too, either way. So, and then what am I going to do with that 12? Equal minus 12. So that's what, 64 divided by 16. So what does x equal, guys?
4.
X equals 4. So that's the first part of my question, right? Because it says find x. What else does it tell me to do?
I'm missing some.
Find the missing side length. So what do I do with that? Bless you. Just plug it in. So does it matter which one I plug it into? Which side? Because either way they're going to be the same. So I would just, 5 times 4 is 20 plus 12. What is each side length going to be? 32. Okay. It doesn't really give me any units or anything. If it said some kind of measurement there, then I would put that.
So we don't have to find like the bottom side AC?
How would you find the bottom side?
Yeah.
Does it tell you anything about it?
No.
No. So it doesn't give me any information. I think when I actually made the notes, there was a 17 there. You'll probably notice a lot of my notes have the number 17 because that was my number and it's close to my heart. But
Wait, you missed the note?
these, that's why they're easy.
Wow.
Nah, it's an easy chapter.
Thanks.
Y'all will probably hate me again in chapter 5, but it's okay.
It's not okay to think it's
It's not okay to hate, but this is a fairly easy unit. Well, at least this part. So yeah, you can't really find AC just because it doesn't give you anything. If it gave you a measurement to find, then you would plug it in as well. Any questions on that? Feel okay? So that's the same thing we've been doing. Go ahead and try practice 5 then. All right, cool. So then if we look at this last example, find the measures of the sides of triangle RST, sketch the triangle, and classify the triangle by its sides. I'm not going to make you guys sketch the triangle because we didn't put graphs on there. So if you would like to draw it out to the side, if you're more of a visual person and you need to see, oh, well, these are probably where my points would be, this is kind of what it would look like, then by all means go for it, but I'm not going to penalize you if you don't sketch it. But what does it give me here? it gives me points. So how am I gonna figure out what my sides are? Distance formula, yeah. So again, some of us have it memorized. I'm not going to make us memorize it. It is the square root of x2 minus x1 squared plus y2 minus y1 squared. So yeah, when it just gives me points, I'm going to have to use that distance formula to find what the lengths of each side is, and then compare them from there. So which one do we want to do first? Which side do we want to find? Because I need 2 points, right?
RS.
Okay, if I want to find RS, we'll do RT next, Brian. So if I'm looking at RS, I label my points. I trust that we know how to do this, so I'm just going to label them that way. So what are we going to plug in? 2 minus 0 squared plus 5 minus 2 squared. From there, we can plug it into the calculator. We can do mental math. It really just depends on what we like. So 4 plus 9. What do we get for our... How much? 3.6. Yeah. Oh, that's all cut off there. Oh, no, just kidding. It showed up. Yeah, so either way, whether you do the math in your head, whether you do it in the calculator. So I have the length of one side. I heard Brian say he wanted to find RT next. So just do the same thing, right? This is going to be the only part that's tedious, is having to do the distance formula the 3 different times. But it still shouldn't be too terribly bad. So RT, I'm just going to label this x2 and y2 since I already have my other ones labeled. And I have 4 minus 0 squared plus 2 minus 2 squared, right? So what do we get for RT? I heard different answers. That's what I got. What's everybody else getting with this?
15 RT.
So square root of 16 or 4. It just depends if you did you do a different triangle or a different length?
I was doing
ST. And what did you get for ST?
3.6.
ST.
So it's this.
Yeah, so plug it in, do the same thing. If you did it, so this would be x1. Whoa, goodness gracious. x1, if I can stop moving the page and write. So I would still have, what is it, 4 minus 2 squared plus, what's there, 2 minus 5 squared.
3.6.
Yeah, which as Kaylee said, square root of 13, 3.6. Yeah, so that's the thing I have to look at. Well, I have one side that's 3.6, a side that's 4, and a side that's also 3.6. So how many there are the same? 2. So if I have 2 congruent sides, goodness, I cannot write on this today. 2 congruent sides, well then it's going to be an isosceles triangle. Okay. Wait, what? We're good? Anybody have any questions about anything we did here? No? Not too terribly bad? Okay, so go ahead and try practice 6. So it's doing the same thing. You're going to have to do distance again. I know it seems kind of tedious, but it's not too terribly bad. So go ahead and try the practice. No? So if I have no congruent sides, what kind of triangle is it going to be? It is a scalene triangle. Okay. If you had a graph, you could graph all of them and you would see probably visually. I don't like doing that though because